We are pleased to have Dr. Gwen Petro with us today to talk about the validation of psychometric instruments. And I think as many of you know, Dr. Petro just joined, actually it's been about 6 months since she joined the RDAC and the Survey and Qualitative Methods Core over here at Dana-Farber. Dr. Petro brings nearly a decade of experience designing and validating self-reported survey measures with deep expertise across the full instrument development process, from item development and analysis to sampling strategy, longitudinal study design, and mixed methods research. Her work is grounded in advanced quantitative and psychometric approaches, including classical test theory, item response theory, factor analysis, structural equation modeling, and mixture modeling. Dr. Petro earned her PhD in communication at UC Santa Barbara, where her research focused on empowering people to use digital technologies in ways that support health and well-being. She has also taught at UC Santa Barbara and Providence College, and prior to graduate studies, she worked in market research for a health information website. That experience continues to inform her practical, real-world approach to measurement. We're excited to learn from her perspective on what it takes to build instruments that truly measure what we intend, and to do so with rigor, transparency, and confidence. Please welcome Dr. Petro.
Hi, everyone, and thank you so much for that introduction, Carol. So I'm Gwen. I'm the survey methodologist at the Survey and Qualitative Methods Core, and also the Research Design and Analysis Core established by the U54 grant. And today I'm going to be talking about assessing and establishing the validity of psychometric instruments. If you have any urgent questions, you can certainly post them in the chat or raise your hand. We'll do our best to monitor the chat over the course of the talk, although it's possible that I might just not notice, so apologies in advance. Otherwise, I will leave some time at the end to give you some time for questions. But otherwise, I'm going to go ahead and get started with our agenda for today. So I'm going to begin this talk by discussing some of the basics of psychometrics. Then I'll outline some criteria for assessing the validity of psychometric instruments, and then go through the process of developing a novel psychometric instrument and establishing its validity. And in doing so, here are some learning outcomes I hope that we can achieve, which include increasing your awareness of the key concepts and primary approaches to psychometrics, improving your ability to scrutinize existing psychometric instruments, and ultimately empowering you to develop and validate novel instruments to address any measurement challenges in your area of research. So just to begin with a quick definition of psychometrics, it is the study of measurement, specifically with respect to psychosocial phenomena, which are increasingly becoming a focus in healthcare research, and more specifically cancer research. And psychometrics frequently involves the measurement of latent constructs. Many of the patient and clinician reported outcomes that you might be interested in measuring are latent constructs. And you might be asking yourself, well, what are latent constructs? Well, there are some traits that we can observe directly. So these are things like temperature or blood pressure, for example. They're fairly easy to measure. However, other traits, known as latent traits, I'll use this term interchangeably with latent constructs, cannot be observed directly. So these are things like your knowledge or beliefs, your attitudes, or maybe your motivations. So these are things that exist abstractly in people's minds. If any of you have ever seen the musical Rent, they ask, how do you measure a year? Well, you can measure it in 525,600 minutes. That is a more directly observable quantity. Or you can measure in love, which is a latent construct. So although we can't directly observe these latent traits, we can measure indicators of them. So, for example, if we're interested in measuring the latent trait of biology knowledge, we can look at indicators such as whether someone correctly answers a question on a biology exam. Or if we're interested in the latent trait of physician trust, we can measure indicators like people's agreement with the statement, your doctor will do whatever it takes to get you all the care you need. And then ultimately, we would combine multiple indicators to form a composite score to take a measure of these latent constructs. But really the big question in psychometrics is how do we know whether our instruments are truly properly measuring something that we cannot directly observe? And this is a really important question, given the serious consequences of flawed measurement. So, of course, we don't want to be disseminating false or misleading information. And as a result of misinformation, we don't want to waste valuable time, money, or other resources on lines of inquiry that maybe aren't going to be fruitful or interventions that aren't going to be effective. We also don't want to misdiagnose people, which can lead to unnecessary or harmful interventions. And then at a more macro level, we don't want to invest in unhelpful healthcare programs and policies. So again, the process of measurement is really important. Fortunately, there are some established processes and criteria that we can use to evaluate our psychometric instruments and ensure that we are measuring things correctly. So here's one process that I'm going to walk through today. It was developed by a group called COSMIN, the Consensus-Based Standards for the Selection of Health Status Measurement Instruments. So I will go through this process. I'll also include some of my own additions and some examples. And I'm going to begin by talking a bit about instrument selection. So let's say you're interested in measuring some latent construct. You'll want to begin by identifying what instruments exist already to measure this in whatever content area or population that you're interested in studying. So let's say you're interested in measuring the latent construct of health literacy. Well, as of 2022, there were over 160 different instruments measuring health literacy. So that can be a bit overwhelming to select the right one for your study. And right off the bat, you can eliminate some that might just not be relevant to the content domain that you're studying. So there are some health literacy instruments that are specific to mental health literacy or electronic health literacy, and maybe those aren't going to be relevant for your study. There are also some that maybe are going to be developed for a different population that you're interested in. There are some instruments that are specific for youth health literacy, for example. So you might eliminate some. You can also eliminate instruments that just aren't feasible or don't fit your definition of health literacy or whatever construct it is that you want to measure. So, for example, here's one health literacy instrument called the Rapid Estimate of Adult Literacy in Medicine. And they define health literacy as a patient's ability to pronounce common medical words and lay terms for body parts and illnesses. So this is a very specific aspect of health literacy, and you may or may not be interested in that particular aspect. Maybe you want to measure health literacy a bit more holistically. Another thing to note about this instrument is that it requires an interviewer to administer it. So maybe that's just not going to work. It's not going to be feasible for your study. Maybe you want a self-reported measure. So you can contrast that with another measure of health literacy, the test of functional health literacy in adults. It defines health literacy as a patient's ability to read and understand things that they encounter in a healthcare setting, like pill bottles and appointment slips. And so this gets at more of the numeracy aspect of health literacy. And again, that may or may not be what you're interested in measuring. And here's yet another instrument measuring health literacy, the All Aspects of Health Literacy Scale, which looks at the capacity of an individual to obtain, interpret, and understand basic health information and services. And so, as you can see, this instrument is a little bit more holistic. It encompasses a few different domains of health literacy. And it's also going to take measurements that are a little bit less objective because they rely on someone's self-evaluation of their own understanding of health information. And maybe you like that definition, but this instrument is just a little bit too long. Maybe you already have a lot of other instruments included in your study. You might use something like the brief health literacy screen, which is a little bit similar to the previous measure, but this includes only 3 items. So again, you'll want to start by identifying what instruments exist to measure your construct of interest, and maybe you can narrow that down a little bit, maybe to just a few instruments or maybe just one. Once you've done that, you'll want to retrieve data on the psychometrics for these existing instruments based on what's available in the literature. And then you'll compare these to predefined criteria. And fortunately, Cosmin has outlined some criteria that you can use to evaluate measurement instruments. They also offer a list of criteria and statistics that you can look at more specifically for each of these domains. But just to refresh your knowledge with some quick definitions, validity is really going to be the most important criteria for evaluating measurement instruments, and this deals with whether an instrument measures what it intends to measure. There's no single metric to assess the validity of psychometric instruments. We wouldn't really say that an instrument is either valid or it's not. It's really going to be more of a spectrum. And so we're going to establish the validity of a psychometric instrument over time as evidence compounds to support that it is indeed valid. And so, again, very important, the validity of our results depends on the validity of our measures. So for example, if we're testing a new health intervention and we find a null result of the intervention on some patient-reported outcome, we want to be sure that this is not a type 2 error, that there indeed was no effect of this intervention, and that our null effect is not due to some faulty measure. Another criteria for evaluating measurement instruments is reliability, which deals with whether an instrument produces the same scores if administered by different people or at different times. It also deals with internal consistency, so whether or not the indicators that you've used to measure your construct are consistent with one another and related to one another. And it is inversely related to measurement error. A third criteria is responsiveness, which involves changes in scores on your measure before or after a treatment or over time, or between treatment and control groups. And you would typically assess responsiveness by considering effect sizes and comparing that to the minimally important difference, which is the smallest change in a patient-reported outcome measure that is perceived by patients as beneficial or that would result in a change in treatment. And so the minimally important difference is going to vary depending on the exact population and context. There's not really a set criteria. So I now just want to alert your attention to a few common measurement issues involving these criteria that I see come up often. The first is issues of construct validity. So you'd be surprised by how many times I come across an instrument that is measuring something that they don't really clearly define. So we can't really measure something if we don't exactly know what it is specifically that we're measuring. That is certainly an issue. You'll also encounter issues of face validity, which involves a mismatch between the construct that you want to measure and the instrument that you're using to measure it. So for example, if we go back to that brief health literacy screen that I showed previously, these authors who develop it define health literacy as the ability to perform basic reading and numerical tasks required to function in a healthcare environment. But if you take a look at their items, there really isn't anything getting at that numeracy aspect. And so I would say that there isn't really a great fit between their definition and their instrument. It's an issue of face validity. Um, you also might see issues of ecological validity where the instrument and its items don't really generalize to things that matter in the real world. So, for example, one review article found that there was a weak relationship or no relationship between many neuropsychological tests and measures of everyday cognitive skills. Um, and these first few criteria are sort of things that you would sort of judge more qualitatively. There, again, isn't really going to be an exact statistic that you can use to assess these things. It sort of requires your own judgment. Whereas that's not the case for these the criteria that I'll discuss next. So you'll see sometimes issues of content validity. This can come up with single item measures, so you'll want to avoid those. And that's because a single item, first of all, isn't going to be very responsive. It's not going to capture that much variation between people or over time. And also, typically, they're just not going to encapsulate every aspect of these complex, latent constructs that we want to study. Sometimes you'll also see instruments that have sort of a haphazard selection of indicators. So it seems like someone came up with a list of scale items and just sort of threw it into their study without really doing any psychometric assessment or going through any more rigorous process to validate their instrument. And that can be problematic. You also sometimes see issues of reliability or internal consistency where people will combine multiple scale items into a composite score without really doing any analysis to establish that this is appropriate. You might see issues of cross-cultural validity where an instrument is applied to a population where it's not appropriate or hasn't been tested. And finally, issues of responsiveness. So some measures just don't really produce very large effect sizes. So once you have identified some instruments and evaluated them on these criteria, you'll have to make a judgment as to whether or not they seem adequate. If they don't, then you might have to develop a new instrument to measure what it is that you want to study. And if they do seem adequate, you'll then want to ask yourself whether the instrument has been validated in the population that you want to study. And so you'll want to define your target population in terms of the language, first of all. So if it's not enough to just simply translate an instrument into a new language, you'll want to go through a more rigorous process of revalidating that instrument. You'll also want to make sure that it's been tested in the same geographic location and culture that you want to study and with a similar demographic group. And then specifically in healthcare research, you'll want to see whether or not this instrument has been tested in patients at the disease stage that you want to study or with the same type of cancer that you're interested in. If it has been tested in your target population, then that's great. Easy peasy, you can use that existing instrument. If not, however, you will want to pilot test the instrument in a small sample of your population and then see whether or not it seems like it is adequate. And there are established procedures for testing measurement and variance between different populations, but I won't get into that here. So if you find that the same measurement model does not apply to this new population that you want to study, again, you might have to develop a new instrument because maybe it just isn't appropriate for that population. To give you an example of where that is the case, there were some researchers who wanted to study quality of life in people who had been living with cancer for a long time or were cancer survivors. And so the standard instrument to measure quality of life in cancer patients is the FACT or functional adjustment to cancer therapy. You might have seen the scale before. It's very commonly used, and there's really nothing wrong with this scale. But the researchers noticed that the items were really more relevant to people who had been more recently diagnosed with cancer and were in active treatment. So they decided to develop a new instrument called the Quality of Life in Adult Cancer Survivors scale. And so they adopted many of the instruments from that existing fact scale, but they also modified some of them and created some new items that were going to be more relevant to their target population. So I'm now going to take some time to walk through the instrument development process. So, sort of as a pre-step to this process is considering who it is that you intend to use the instrument that you're developing and how you intend for them to use the data that it produces. So, for example, maybe you think that healthcare organizations will want to use this instrument for process improvement. Or maybe you intend for clinicians to use it for diagnostic or treatment decision making, or maybe for policymakers to evaluate new programs or health interventions. And these decisions are really important to make because they're going to affect subsequent stages of the instrument development process. So it's important to clarify this up front. And once you've thought a bit about that, you'll want to start by determining the construct that it is that you want to study. And so, of course, you'll want to really clearly define the construct that you are interested in. This might involve consulting the literature. If it's something that exists, you might turn to a theoretical framework or model for a definition. But if it is maybe something newer or something that hasn't been studied as much, you might collect some qualitative data to inform your definition. You'll want to consider the dimensionality of your construct. So is this something that is unidimensional, or maybe are there multiple dimensions or aspects that would require subscales in your instrument? You'll want to compare and contrast your construct with similar constructs. And again, ensure that what you're measuring is really something unique and different that requires this new instrument. You'll want to consider the relationships between this construct and other constructs that it should predict, as well as set some boundary conditions for the population where you would observe this phenomenon, as well as the context in which it would occur. It can also be helpful sometimes to create a conceptual diagram at this stage. So for example, here's a conceptual diagram that shows the dimensionality of emotional intelligence. It sort of breaks it into these like 4 dimensions on a couple of criteria. Here's another diagram that compares and contrasts a few similar constructs like sentience and agency and self-awareness. And here's another, this is a concept map that shows how a particular concept is related to other concepts. So these can all be helpful in this stage of the process. And once you've done that, you can begin to generate an initial item pool. And you'll really want to start by generating a long list of items that you can always pare down later. You might do this by using a deductive approach that's informed by the literature, where you're maybe combining items from existing measures, or maybe you're adapting or modifying some of the wording for your instrument. You can also use an inductive approach where you're gathering insights from key stakeholders like the intended users or patients or caregivers or clinicians who are going to be interested in this instrument. And you can do this using interviews or focus groups or surveys or even direct observation. You can also crowdsource items using techniques like the Delphi method. The exact number of items is really going to vary. As I mentioned, it can be helpful at this stage to come up with a long list of items that you'll narrow down over time. But the exact number of items, it's going to depend on what's sufficient to address content validity and make sure that you're really encapsulating all aspects of this construct that you want to measure. And for multidimensional constructs, you'll want to have at least 3 items per dimension. You'll also want to consider your measurement model, which describes how the items map on to the construct that you are measuring. And there are 2 measurement models that you might choose from. There's the reflective model and the formative model. So with the reflective model, this latent construct exists independently of the measures or the indicators. And so the construct is the cause of the indicators that you would be measuring. Whereas with the formative model, it's the opposite. The latent construct is formed by this combination of indicators. And so the indicators are the cause of the construct. With the reflective model on the left, the items or indicators are going to be fairly interchangeable. They should be highly correlated and they should have similar antecedents and outcomes, whereas for the formative model, the indicators are not interchangeable and not necessarily correlated, and they also might have different antecedents and outcomes. And then with the reflective model, there's going to be an identifiable error term. And just to give you a couple of examples to help illustrate this, if you consider the latent construct of depression, depression is going to be the cause of indicators like low mood, hopelessness, and fatigue. So that would be the reflective model. Whereas for a construct like socioeconomic status, it is going to be caused by the indicators of education, occupation, and income. Those are going to be the causes of socioeconomic status. So once you have your initial item pool, you'll also have to think about the response scales or options that you want to use for your instrument. And there are a few common types of responses that you might see. The first are dichotomous response options, often just yes or no type of questions. You may also see Likert scales, which are a series of ordered categories. So for example, people might be asked to indicate the extent to which they agree or disagree on a series of statements or items. You can also rate things like quality or frequency or intensity. But again, keep in mind that these are ordered categories. And so if you look at this diagram here, if you look at sort of this first line, you can't assume that there's equal distance or equal size of each category. It might look something more like this line on the bottom, where there's not equal spacing. You also sometimes see semantic differential scales, which are paired adjectives at each end of the scale. So you might be rating yourself on a scale from maybe extremely depressed to extremely happy, maybe evaluating like how you felt the previous day. You'll want to consider whether to include a midpoint or a neutral option in your scale, as well as whether to consider options like don't know, none of the above, or not applicable. And there are pros and cons to including a midpoint, as well as these sort of not applicable, none of the above options. So if you don't include them, people might simply guess, right? They may be forced to state more explicit opinions or beliefs where they don't really have such strong ones. However, if you do that, then you do have nicer ways to categorize whether or not people agree with certain items. But if you do choose to include them, it might make it easier for people to respond to your items, especially if they are maybe more neutral. But then it can cause people to sort of just get lazy and continue to select the neutral option or don't know. You'll also want to consider the number of response options. And so if you have too few, you might not really get that much variability in your data. But if you have too many, it can be really difficult for people to choose. And so typically you'd see somewhere between 4 to 7 response options. And again, whether or not it's an even or odd number will depend on if you include that neutral or midpoint option. Finally, you'll want to consider the mode of administration for your instrument. Is it going to be self-reported or does it require an interviewer? Is it going to take a while to score people's responses, or will it be pretty easy to compute a summary score? You might also consider the timing of when it should be administered. So if you're maybe evaluating the effects of a particular medical treatment, do you want to administer this instrument immediately after the treatment? You want it to be a week later or maybe sometime within that month? These are all things that you'll want to consider. So once you've done all of that, you have sort of an initial version of your item. You'll want to have it reviewed by some experts to get some feedback. So first off, you'll want to have a review by your end users of your instrument in order to assess its face validity and content validity and really make sure that it seems to be measuring what you intend to measure based on your definition. You might also conduct some cognitive interviews with members of the target population to ensure that they're interpreting the items as you intend and find the measure generally acceptable. These typically use the think aloud method, where you try to see how people came up with their responses to each item. And you would typically conduct about 3 rounds of cognitive interviews with 5 to 15 participants per round. And then you would revise your instrument between each round and retest it. And with each of these methods, you'll want to aim for a somewhat representative sample if possible. Once you've done that and maybe made some revisions, you'll then want to conduct a pilot test of your instrument in a small sample of your target population to identify any issues before you spend your resources on a larger sample. So for this initial pilot test, you'll want to aim for around 30 participants. That'll allow you to get a sense of the distribution of your data. And again, aim for a somewhat representative sample. And so the pilot testing will allow you to see response frequencies for those categorical variables, as well as score distributions for continuous variables. You'll also get some metadata from your pilot test, so you'll get a sense of the time it takes people to complete this instrument. If it seems like it's taking a really long time, then you might want to shorten it. You'll also get a sense of response rates. So if it seems like a lot of people are skipping or not responding to a particular item, or maybe selecting don't know, then there might be an issue with that particular item and you might have to revise it or remove it. You can collect qualitative feedback in your pilot test as well. So you can include text boxes for people to provide their thoughts about the item as a whole or the instrument as a whole or specific items. You can also collect some quantitative data. Again, have people rate either the specific items in your instrument or the instrument as a whole in terms of things like comprehensibility, acceptability, and comprehensiveness. So after your pilot test and your expert review, you will want to go through a process of item revision where you might modify or remove some items, again, based on that expert review and those pilot test results. And then you'll have some version of your instrument that you can test with a larger sample in a bigger validation study. Okay. So then you can finally trial your instrument in a larger sample of your target population. And you'll want to make sure that your measurement model you'll want to be testing your measurement model and see whether or not it needs to be refined further. You'll also want to compare scores on your instrument to measures of the same construct that already exist or measures of related constructs. And when you do this, there are a couple of different approaches to psychometrics that you might choose from. I'll go through those quickly here. The first is classical test theory, which is the standard approach. It's been around a little bit longer, more people are familiar with it, which measures a person's true score on some attribute of interest, your latent trait. And so people's observed scores that are captured by your instrument would be a combination of their true score as well as some measurement error, which will hopefully be kept to a minimum. Polytomous items, items with multiple response categories, are going to be more common. And then items in your instrument can be summed or averaged together to produce a composite score. And these scores will be an ordinal level of measurement. So it'll tell you how people rank in comparison to one another on this construct of interest, or you can compare groups with respect to one another. When you're using this classical test theory approach, you're typically more interested in evaluating the measure in its entirety. And so there are some statistics that exist to assess this, such as Cronbach's alpha, which measures the internal consistency of your items. There are also statistics that have been developed to assess specific items as well, and whether or not there are items that you might want to remove to improve the validity of the scale. And then there are some approaches to assess the dimensionality of your measurement model. So this would be things like factor analysis. So to give you an example, we can return to that all aspects of health literacy scale. This was developed using classical test theory. And so, as you can see, they have a series of items that people were mostly asked to evaluate on a Likert scale, measuring frequency for things like how often they need help filling in official documents. And then the authors initially categorized these items into a few different dimensions, including functional health literacy, communicative health literacy, and critical health literacy, according to existing theoretical frameworks. They then conducted a factor analysis to see whether or not these items that they developed loaded on to these various factors, as well as how many factors they were able to identify. So initially they thought that there would be 3 factors. However, they ultimately found that a 4-factor solution fit the data a little bit better. They saw that most of the items or all of them loaded pretty highly onto just 1 factor, which is what you want to see. And again, their measurement model was a little bit different than what they initially hypothesized. And once you've done your factor analysis, you can create a nice factor diagram showing which items load onto which of your factors, your error terms, which are on the right, as well as the relationships or correlations between your various factors. So some strengths of this classical test theory approach are that it is, again, pretty well known. It's also really useful for determining the dimensionality of your latent construct, especially in those early stages of instrument development. There are some weaknesses, however. So a greater number of items in your scale can inflate its reliability. And so this incentivizes people to include redundant items. It's also a bit less reliable for scores at the extreme ends of your scale. And your estimates are going to be highly sample dependent. And so every time you are using that instrument that's been developed using classical test theory, you'll want to at least compute some statistics like Cronbach's alpha to make sure that, again, you have some internal consistency or maybe conduct a factor analysis. So an alternative to this classical test theory approach is item response theory, which is a bit more sophisticated. And this explains the relationship between one's level of an attribute of interest and their probability of a particular response to each item. In this approach, dichotomous items are a bit more common. Items are going to be evaluated in terms of their difficulty or severity, and then people are going to be assigned a score on your latent trait, and these scores are going to be an interval level measurement, so it's going to be more precise than what you would get with classical test theory. In item response theory, there are some statistical models to assess item difficulty, like the item characteristic curve for dichotomous responses, which you can see at the top here. Beneath that is a similar type of diagram for polytomous response scales. But what you can see is that on the x-axis, we have this varying levels of whatever ability or trait it is that you wish to measure. And then the curves represent people's probability of endorsing each item or dichotomous items. So as you can see, this blue item is a bit easier. People at this lower end of the trait are more likely to endorse it, whereas you have to be at a higher ability level to endorse this green item over here. It's going to be a bit more difficult. There are also models in this approach to assess item discrimination. So for example, you can see that this red item in this diagram here can pretty easily distinguish people at sort of this mid-level of that particular ability that you're studying. Whereas if you look at this blue line, it's much better at discriminating among people at all levels of this trait. So these higher and lower levels as well. You can also combine these item level scores into measures assessing or into statistics assessing the reliability of your entire measure, such as the scale information curve. So for example, this shows us that this scale in its entirety is really good at discriminating among people at this lower end of that trait. And this is inversely related to your measurement error. So measurement error is going to be the lowest for those lower levels, whereas it functions a little bit more poorly at those higher levels. And a cool thing about item response theory is that you can produce something called a right map. That's WRIGHT, that shows people and items on the same scale. So this was a right map developed for an instrument measuring physical functioning. And you can think of each item as sort of like a hurdle, where the items that are shown lower in this diagram are going to be lower hurdles. They're a bit easier to clear. And then items that are higher are going to be higher hurdles. They're higher for people to clear. And then on the left, you have a histogram of your responses and people's scores in your particular sample. So as you can see in this sample, for items like getting around inside your home, everyone was able to clear that hurdle. Everyone was able to do that. Whereas for things like walking 1 block, most people could, but not everyone. Walking a mile, more people could do, fewer people were able to accomplish. And then things like vigorous activities at the very top of this diagram, only a few people were able to clear that hurdle. Just to, again, give you another example related to health literacy, there was a scale called the Health Activities Literacy Scale that was developed using some existing data. And this was a data set that contained a variety of different types of literacy tasks. And so the authors used this data set that came from a sample, I think it was a representative sample of US adults, and they categorized these tasks among these 5 health literacy dimensions. And they did this sort of a priori. And then for each of those tasks, they used item response theory to assign it a difficulty score. So if we look just at the health protection dimension, for example, we could see that the task related to bicycle helmet safety and interpreting like some diagram or some written information related to that was much easier than the item related to nuclear power plant perils. And then they came up with some thresholds for assigning people to various levels of health literacy based on their scores overall. So there are certainly some strengths to using item response theory. It provides you with more precise measurements. It also provides you with additional information beyond what you would get through classical test theory models. It allows you to administer just a subset of items, which is kind of nice. So you could shorten your assessment, and you can also do cool things like computerized adaptive testing using item response theory. It's also important to note that models developed using IRT should behave similarly across different samples and populations. And so you don't need to revalidate your measurement model every time you reuse that instrument. However, some weaknesses include that IRT is a little bit less well known than classical test theory, and it may require a larger sample size for those additional initial validation studies. And so finally, just to compare those two approaches, classical test theory really focuses on the strengths of an instrument as a whole, whereas item response theory is looking at the strength of individual items and their ability to discriminate among your participants. In terms of administration, classical test theory instruments are not valid unless you include all of the items in that instrument, whereas with item response theory, you can just include a subset of items. And you also don't have to revalidate your instrument every time you are administering it in a new sample. You can also sometimes use these two approaches in conjunction. So you can use classical test theory maybe to get a sense of your measurement model or the dimensionality of your construct in those earlier stages of instrument development, whereas you can use item response theory to evaluate the individual items in your instrument. So once you have conducted some sort of initial validation study using either classical test theory or item response theory, you'll have a final novel instrument that maybe isn't necessarily final, but good enough to publish and get out there as long as it sort of functions as you anticipated. But again, I say it's not necessarily final because it's possible that as people continue to use your instrument and sort of test it over time, they might make modifications to it. They might revise it. Maybe they add additional items, or maybe they adopt it, or they adapt it into different languages, or test it in new populations. And they might find, for example, that your measurement model doesn't fit in a new population, or maybe, they need to change the factor structure slightly. So again, over time, evidence will compound. Ideally, that will strengthen the case for the validity of your instrument. So just to give you a few final thoughts on measurement. First of all, if your instruments don't measure up, then your results are essentially meaningless. So again, psychometrics are very important. We want to make sure that we are using valid measures. I encourage you to scrutinize existing measures, even if they are well-established, quote unquote, valid measures that have been used time and time again. Again, you want to make sure that they are appropriate for your purposes. And also ask yourself, can we be measuring this construct better? Keep in mind that developing and validating psychometric instruments is a complex process, and it's going to take time, but ultimately it's going to be worthwhile. I also encourage you to think beyond just the steps outlined here today and explore other creative ways to enhance the validity, not just of your measures, but also of your research design as a whole. And finally, I urge you to consider the person who will be responding to your instrument, not just the data that you plan to collect. Especially in healthcare research, we often are administering these instruments at really sensitive, critical times in people's lives. So we really want to make sure that we are asking questions and collecting data responsibly and ethically. So that concludes my talk today. Thank you so much, everyone, for listening. I encourage you to reach out if you have any measurement-related questions or you want a consultation for your particular study.